Welcome to today's class with Comrade Stephen Cornelius Ngombianga. I'm still going to be taking you on the rules guiding IUPAC nomenclature. The rules guiding IUPAC nomenclature. So in organic chemistry, today is our class 3. So I'm still going to urge you, go to our first class where we're able to define organic chemistry, talk about the terms used in organic chemistry. Then in our second class, that's when we started with the rules guiding IUPAC nomenclature. So you can also as well subscribe to this channel, which is very, very important. Subscribe as we keep updating you. So today we are going to continue with our rules guiding work, IUPAC nomenclature. And in our second class, I told us that the basis of naming organic compound lies on the terms used in organic chemistry and also the IUPAC rules and regulation. So please, you must know the terms used in organic chemistry very well, and you must also know the key rules of IUPAC nomenclature for you to be able to name a compound. So as we proceed from where we stopped, I believe compounds will be very simple and easier for you to name. So please subscribe to this channel. As I said, make sure you go to the subscription box and click on it as we proceed for the business of today. So last time we said that the first rule says that we should choose the longest continuous carbon chain. That's what the first rule is saying, that we should choose the longest continuous carbon chain. So after identifying the longest carbon chain or the longest continuous carbon chain, then what we need to do is to number the longest continuous carbon chain. So if we choose the longest chain, the next thing is for us to number the chain. So after numbering the chain, we looked at what we call substituents in our last class, and we said these substituents are secondary structures, or they are atoms that are attached to the main structures. So very, very important. Those things are things that we need to learn. So today we are going to the rule number 4, which is saying that if we have 2 or more similar substituents, then we can name it as di if the substituents are 2, and tri if they are 3, and tetra if they are 4, and etc. So let's see an example on this, which is going to help us. So number 4 said that when we have 2 or more similar substituents in the structure, we should name it as di, we should name it as tri, which is 3, and we should name it as tetra if it is 4. So let's try to see this structure. For example, so if I have a structure like this, if I have a structure like this, or that is having something of this nature, if I have a structure like this, for example, so if I have a structure like this and I want to name this compound, for example, now look at this. We said if there are 2 or more similar substituents. So can we check if we have a substituent in this structure? Yes, there is a substituent here, which is bromo. There's another substituent here at this carbon. There's no substituent here, there's not here, and there's not here. So if I want to number this, remember that the rule number 3 says we should number in such a way that the substituent should have less number. So you first of all consider your longest chain. So there is not any branch chain on this structure, but if I want to consider my longest chain, it's either like this or like this. You understand? It's like this or like this. So now if I want to number, which is rule number 2, it says we should number in such a way that the subsequent should have what? Less number. So where do you think we should begin our numbering? Our numbering should start from here, from this side. So we are numbering from here 1, 2, 3, 4, 5. So if you number from here, our subsequent we have 1 and we have 2. Because the subsequent, these are the subsequent, the bromo and the bromo here. So they are in 1 and 2. But if you number from here, let's assume you number from here. Let's assume you number from this side. 1, 2, 3, 4, 5. So if you number from this side, can you see the number of our subsequent? The number is 4 and 5. 4 and 5. 4 and 5. So in this case, if you number from from left to your right, the number of your subsequent is 4 and 5. If you number from right to your left, the number of your subsequent is 1 and 2. So we said, the rule says we should number in such a way that the subsequent should have less number. So if you consider this now, the correct way of numbering should be from here to this side. So that your subsequent will have what? Less number. So at carbon number 1, I have a subsequent which is Br. So it will be 1 bromo. Then at carbon number 2 also, I have a subsequent which is Br. It will then be what? 2 bromo. So this 1 bromo means at carbon number 1, I have a bromo. Then this 2 bromo means at carbon number 2, I have a bromo. So can you see that these are 2 similar subsequents? These are 2 similar subsequents. So because they are 2 similar subsequents, we name it as di. We will name it as what? Di, because they are what? 2 similar subsequents. So if I want to, and this is 1, 2, 3, 4, 5, this is pentane. So if I want to name this one now, this one would then be 1, 2 slash di bromo pentane. So this one will be 1, 2 dibromopentane. Why is di? Because we are having 2 similar subsequents, and the name of those two similar subsequents are what? Bromo. So at carbon number 1, I have a subsequent. At carbon number 2, I have a subsequent. Then since the subsequents are similar, I call them what? Di. They are 2 similar subsequents. I call them what? Di. And the name of the subsequent is bromo. Then the structure entirely is what? Pentane. So I have 1, 2 dibromopentane. I guess this is clear. That's good. Now, so they said when you have 2 or more similar subsequents in a structure, you should name it as di, tri, or tetra. So for example, let's move to the rule number 5, the next one. The next one said, if we have 2 or more different subsequents in the structure, we should number it in what? In alphabetical order. Or we should name it in what? Alphabetical order. So if you have 2 or more different subsequents in a structure, you will number and name the structure or the subsequents in alphabetical order. So let's assume that I have a chloro here. I have Cl here. I have a Cl here. Then I have maybe a Br here. So how do I name this? So first of all, in alphabetical order, B comes before C. So this structure should still be numbering from here to this side, from this side to this side. So after numbering now, in alphabetical order, B comes before what? C. So if I want to name this one also, now you bring out your substituents. At carbon number 1, I have a substituent 1, which is bromo. So that is, I have one word, bromo. At carbon number 1, I have bromo. And at carbon number 2 also, number 2, I have another bromo. At carbon number 2, I have bromo. Then at carbon number 3, I do not have any bromo here. I do not have any substituent at carbon number 3. And at carbon number 4 also, there is not any other substituent. But at carbon number 5, I have what? A substituent which is called chloro. It's called what? Chloro. So if I want to name this in alphabetical order, it will be 1,2-dibromo, 5-chloro what? Pentane. So this one will be what? This one should be 1,2-dibromo, 5-chloro pentane. So this is 1,2-dibromo, 5-chloro pentane. So can we see the structure? We follow alphabetical order because B comes before C. That's why bromo is named before the chloro. Very, very important. So if you don't know how to name this, they will confuse you in so many objective questions. Because if you start numbering from here, you might see the question in the option. So very important. And another thing you need to note is that this class is for what? It's for JAM. It's for JAM. The class is for JAM student, it's for WAEC student, it's for NECO student, NATEL, and any other exams. So very, very important. So can we see what this rule is saying? Let's go to the last but not the least here on the rules. But as we keep naming organic compounds, I'll be showing you some few rules that should be added to this. But for now, let me just take the last one now for this class. So the last but not the least here is saying that when you have both substituents and functional group in a structure, when we have a substituent and a functional group in a structure, we should number in such a way that the functional group should have less number now, not the substituent. That is, when I have both substituents and a functional group, I should respect the functional group, or I should obey what the functional group is saying. Reason is because the functional group is the parent name. The functional group is what? The parent name. And in our terms used in organic chemistry, we say it determines what? The chemical property of that homologous series or of the compound. So if I have both substituents and a functional group, like in this case, let's assume I have something, a structure like this. So let's assume that I have Br and Br here. So if I have this structure, for example, like this, and I want to number, remember that one of the rules says we should number in such a way that our substituent should have less number. But look at, in this structure, we are having both a functional group and a substituent. So where do I begin my numbering? Where do we begin our numbering? our numbering should begin from this side. 1, 1, 2, 3, 4, 5. Why is this starting, or why is our numbering starting from here? Reason is because when you have functional group and substituent, you respect the functional group because it's carrying what? The parent name, or the functional group determine what? The chemical property of the structure or of that homologous what? Series. So if I'm numbering, I'm not starting from here because of this functional group. That's why we're starting our what? Numbering from this side. So if I want to name this compound will be, this is carbon number 1, carbon number 2, no substituent, carbon number 3, no substituent, carbon number 4, no substituent, carbon number 5, there are what? Substituent. And they are what? The substituent names are bromo. So if I want to name this one, I will say 5, 5, 5, 5, 5, 5 dibromo 1, 2, 3, 4, 5 pentanoic. This is what? Pentanoic. So this is 5, 5 dibromo pentanoic. Now look at here. Why is it 5? You cannot just say, you see at carbon number 5 we have two substituents which are bromo and bromo. So you cannot say 5 dibromo. That's the mistake some persons do make. They will say 5 dibromo. No, you are wrong. 5 bromo, 5 bromo. That's why it's 5, 5. Do you understand? 5 bromo, 5 bromo. So it's 5, 5. Not 5 dibromo. If you write it as 5 dibromo pentanoic, it's very wrong. We'll mark you wrong. So it's what? 5, 5. 5 bromo, 5 bromos. That's why you call it what? 5, 5 dibromo what? Pentanoic acid. So this is very important. I guess by now you should know all the rules guiding IUPAC nomenclature. So now let's start from rule number 1. The rule number 1 says what? We should choose the longest continuous carbon chain. Then rule number 2 says what? We should number the longest continuous carbon chain. Rule number 3 said if we have substituents in the structure, we should number in such a way that the substituent should have what? Less number. Number 4 is saying when you have 2 or more similar substituents in the structure, you should name it as what? Di, tri, or tetra. Then the last but not the least is second to the last is saying when we have 2 different substituents in a structure, we should number it or name the structure in alphabetical order. Then last but not the least said when you have both functional group and a substituent in a structure, you should what? Number in such a way that the functional group should have less number. So can you see this rule that I gave you is quite simple. I tried to simplify this the best I could. So please let me just give you a structure and see how we can follow this rule to name it before we come to the naming of an organic compound properly. So let's use the rules and name this compound. So for example, if I have a structure like this, if I have this structure, for example, if I have this structure, so you need to consider all those things. I have this structure, then let's assume that I have a branch here. I have a branch here. So I have a branch here, and I also have okay, these are normal bones. Or let me just make this one. Then I have something of this nature. So let's assume that this is normal bonding. So this is normal bonding. This is normal bonding. So I have this here. So if I want to name this using the IUPAC rules, if I want to name this compound using the IUPAC rules now, let's try it together to see if we can get it using the rule. You know, the first rule, what do we say? The rule says we should choose the longest chain. So look at it now. I can decide to move from here 1, 2, 3, 4, 5. Can you see? Or 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. These are changed. Or if I move 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So can you see the longest chain now is either I move from here to here or I move from here to here. That's the best thing you need to know. So our longest chain is either from right to left or from left to right. That's our longest chain. So if you choose your longest chain, the next thing is what? Is to number your longest chain. So where do we begin our numbering? From here? No, we don't begin the numbering from here. Remember, there are rules guiding this. So you see the issue with your JAMB or WAEC now. If you number from here to here, you will see the answer in the option. And if you number from here to here, you will still see the answer in the option. But one of these is what? Is correct. So that's why you must know the IUPAC rules and nomenclature. So if you are numbering, you must start from here. Do you understand? Then who will tell us the reason why? 2, 3, 4, 5, 6, 7. You are starting from here. You know the second rule said what? If you choose the longest chain, then you should what? You should number the longest chain. So we just choose it and number. We are starting from here because the next rule said that when you have a substituent in the structure, number in such a way that the substituent will have less number. So you see, we do not follow that rule. Why? Because we are having a functional group. And this is an alkanoid functional group, COOH. So we say in the case where we are having both a substituent and a functional group, you will respect the functional group because it's the parent name. So if you have both substituents and functional group in a structure, you must number in such a way that the functional group should have less number because it's what is the parent name. So that's why we are starting from where? From this very side. So your best way of numbering on this very structure is from here 1, 2, 3, 4, 5, 6, 7. You are numbering your carbon chain. So the next way to see if you can do it properly, I tell you there is no rush in this. Follow each of the carbon and check if you have a substituent. If you have substituents, then you name the substituent with the carbon atom, the number of the carbon atom. So now, this is your functional group. Carbon number 1, there is no any substituent. Carbon number 2, there is no any substituent. Carbon number 4, there is a substituent. What is the name of the substituent? Methyl. Can you see? We say when you have CH3, you call it what? Methyl or methyl. So you write it 4-methyl. So our first substituent is 4-methyl. That's it. At carbon number 5, I don't have substituent. At carbon number 6, I have substituent. 6-chloro, then 6-chloro. So I have what? I have 6-chloro. I also have another word, 6-chloro. Then check. At carbon number 7, I also have chloro. So it will then be what? 7 what? Chloro. So if you can have this, then you should be able to name the compound. Do you understand? And the parent name this is from which homologous series? Alkanoid. This is alkanoid homologous series because of this functional group. So this is 1, 2, 3, 4, 5, 6, 7. 7 is what? Heptanoid. 7 is heptanoid. So now, we say when you have 2 or more similar substituents in a structure, you name it as di, tri, or tetra. But here, look at this structure. We have 6-chloro, 6-chloro, and 7-chloro. So if you want to join the 3 together, it will be 6,6,7-trichloro. So if you want to join this, you now say what? 6, 667. Try what? Chloro. So the name of this one will be 667 trichloro. So now between C and M, which one comes first in alphabetical order? Between C and M, which one comes first? C comes before what? M. So now if you want to name, look at the substituent. You have 4-methyl, you have 6-chloro, 6-chloro, and you have 7-chloro also. So now if you want to name this compound now, correctly now, the name of this very structure is going to be what? 667 try what? Chloro. Then it will be 4-methyl heptanoic. Heptanoic. So can you see? This is 667 trichloro 4-methyl heptanoic. Hope this is simple. So if this is not simple for you, it means you have to go back to the definition of organic chemistry. Look at the terms used in organic chemistry. Then follow our IUPAC rules and regulation. That is, you have to go to organic chemistry 1, 2, and this is 3. So in our next class in this organic chemistry, we are going to name what? Organic compound. So please, as I said, subscribe to our channel, like our channels, and comment. Also, if you have any questions, then you can reach to us through the comment side. We're very free, available, easy to access. We're here because of you to pass your JAM, because of you to pass your WAEC, and because of you to pass your NECO, NAPTED, and any other exams. So make sure you reach us with your questions so that we'll see how we can help you. But I bet you, if you are able to follow this, our classes critically from organic chemistry 1, 2, and 3, you will be able to name this organic compound, because some persons started calling and they are testifying of how simple the organic chemistry is now. So in our next class, we are going to focus basically on naming structures. Our next class, please do not miss our next class, because we focus on naming what? Organic compounds.